We're going to start by looking at the addition of fractions, and we're going to start off by looking at fractions with the same denominator, adding fractions that have the same denominator. And we can look here at 2/3, and we're going to add this to 1/3. And if you look carefully, these two fractions have the same denominator. So when adding these, we simply rewrite the common denominator for both fractions, which in this case is 3, and we simply add the two numerators. In this case, 2 plus 1 is 3, so the answer is 3 on 3, or 1 whole. The same thing that occurs when we add fractions, the same denominator also occurs in subtraction. And when we take a look at these two fractions here that we're subtracting, we have 4/5 and we have 2/5. Again, as I said before, the denominators are the same, so we simply rewrite it. So in our answer, the denominator will be 5. And then if we go to the numerators at the top, we simply subtract 2 from 4, and we all know that 2 from 4 is 2, so our answer is 2/5. What now about adding and subtracting fractions with different denominators? Okay, and we're going to look first at a very simple fraction. Let's say we had 2/3, and we want to add this to 1/2. Okay, you realize in these two fractions now the denominators are different. There are many ways of approaching this problem, but one that I find that is quite easy is to simply multiply both fractions by the denominator on the other side. And I'm going to show you what I mean shortly. So we have on this side, we have 2/3, and then we have over here 1/2. Okay, and we're going to multiply first 2/3 by 2. Okay, and when we do this, we must multiply both sides by the 2. Because our aim here is to find a common denominator so we can perform the operation. Nothing can happen unless we have a common denominator for both fractions. Okay, so we have 2/3, and we're going to multiply that by 2. So 2 2s are 4, and 3 2s are 6, so we have 4/6. Okay, so 2/3 is equivalent to 4/6. If we were to reduce 4/6, we would definitely get 2/3. Okay, and we're going to do the same thing with 1/2. We're going to take the half, and we're going to multiply that by 3. And as I said before, we're going to multiply both the 1 by 3 and the 2 by 3. Okay, so that at the end of the day, we will get 3/6. And if you look at 3/6 and 4/6, or 4/6, you realize that both of them have a common denominator, which is 6. So in this form, we can go back and add the fractions like we were doing in the previous set. Okay, so we have 3, 6, and we're going to add that to 4, 6. Okay, again, we have a common denominator, so it's an easy operation now. You simply rewrite the denominator in both fractions, and we simply just add the 2, and we can do that very, very shortly. Okay, so we're going to add 3, 6, to 4, 6. As I said, we have a common denominator, and once we have a common denominator, we just simply have to add or subtract the numerators at the top. And in this case, we have 6, so the answer is 7 and 6. 7 and 6 is called an improper fraction, and we look at those a little later, okay? And 7 over 6 can also be written as 1 and 1 over 6, which is called a mixed number. And again, we'll be looking at those very shortly, and how you can change an improper fraction to a mixed number, and a mixed number to an improper fraction. So bear in mind, in cases where the denominators are different, we simply multiply both fractions by the denominators, okay, on both fractions, and then that is a way of getting a common denominator. And then once we have that common denominator, we can go ahead and add like how we were adding before. But let's look at this other one. This is 3/5, and we're gonna add this to 2/3. Again, we have different denominators. We have 5 and we have 3. So we need to have a common denominator. So what we can do is we can multiply 3/5 by 3 in the 2/3, and then we can multiply 2/3 by the 5 in the 3/5. So when we multiply 3/5 by 3, as I said, we multiply both the numerator and the denominator by 3. So we have 3 3s are 9, and 3 5s are 15. And then we're going to multiply 2/3 by 5. And note here that we have gotten a denominator of 15, and hopefully when we multiply 2/3 by 5, we should also get a denominator of 15. And once we have that set up, we can go straight ahead and add like we were adding in the first set of fractions. We added where the denominator was the same. So when we add 2/3 to, we multiply 2/3 by 5, we have 2 5s are 10, and 3 5s are 15. So we have two fractions here that the denominators are the same. Okay, we have 9 15s and 10 15s. Okay, and both of them have a common denominator of 15. So it's very easy now to add them. So let's go ahead and do that. Let's just get rid of this this here first. Right. So let's add them now. 9 over 15 and 10 over 15. Very, very easy operation now that we have been able to give both fractions a common denominator. So we have 9 over 15, we're going to add it to 10 on 15. Again, 15 is a common denominator, so we can write 15 as our denominator for our answer, and we're going to simply add the two numerators at the top. So 10 and 9 is 19, 19 and 15. Again, this is an improper fraction where we have the number at the top being larger than the number at the bottom, And again, this can be changed into a mixed number, and as I said, I'll be showing you how to do that very shortly. Your answer is 19 and 15. Okay, let's look at another one. Okay, let's say we had 4 sevens, and this time we're going to take it away from. Right, we can look at these two fractions. Two fractions here, and again, this is a situation where we have the denominators are different, so we have to find a common denominator. But again, this is only one way of doing it, but there are many other ways of arriving at an answer to this particular problem. Okay, but to me this way is much easier. You have 4 sevens, and you're going to multiply it by the denominator in 2/3, which is 3. So we have 4 3s are 12, and 7 3s are 21. Okay, so you're going to multiply both the numerator and the denominator by 3. We get 12 over 21. Then we do the same thing with the 2/3. We're going to take 2/3, and we're going to multiply it by 7. Okay, we know that 2 sevens are 14, and 3 sevens are 21. So we have 14 over 21 and 12 over 21. Again, we have now created a common denominator for both fractions, because 21 is common to both of the fractions. So we can go ahead now and do our subtraction. And of course, as I said before, it's just a matter of rewriting the denominator and performing the operation at the top where the numerators are. So we have 14 over 21 and we have 12 over 21. So we're going to take 12 from 14, and we can simply rewrite the denominator, which is 21. So our answer is, that's very easy, 2 on 21. So this is very easy and straightforward operation. As I said, but there are many other ways of doing it, but I like this one, and that's why I am showing it to you. We're now going to look at improper fractions and mixed numbers. And as I said before, let's look here at an improper fraction. We have 5 over 3. Again, this fraction is top heavy, or the numerator is larger than the denominator. Okay, as I said, this is called an improper fraction. Then we have the mixed number. Okay, and the mixed number simply has a whole number and a fraction. I guess that's why they call it a mixed number. Okay, so let's do a bit of review. So we have an improper fraction is a top-heavy fraction, and a mixed number is a mixture of a whole number and a fraction. Okay, so let's look now at converting improper fractions into mixed numbers and vice versa. So let's look at this one here. We have 7 on 4, okay? To change this into a mixed number, you simply divide 4 by 7, okay? Like how you would do a normal division, okay? So let's do that. 4 divided by 7. When we do that, we get 4 1, and there is a remainder 3. But what does all this information mean? How do you put this information into the form of a mixed number? Okay, firstly, the denominator 4, that remains the same, so that doesn't change. So in rewriting your mixed number, 4 must be the denominator here, okay? The 1 at the top there with the little green mark over, that becomes your whole, and your remainder 3 becomes your numerator in that fraction, so that you have 1 and 3/4. Okay, and if you want to check it, then you multiply 4 by 1, you get 4 ones are 4, and then you add the 3 now. Okay, you get 7 on 4. Let's look at another one. Okay. So let's get rid of this. And we're going to look at 21 on 5. Okay. And we're going to do basically the same thing that we did just now. We're going to divide 5 into 21. So 5 into 21, we know that we can get 4 5s out of 21, and it's going to be a remainder 1, because 5 4s are 20, and 1 is 21. Okay, so let's now set down this information in the form of a mixed number. Oops, sorry about that. Let's see where this 21 here. Remember I told you the denominator in the improper fraction remain the same. So it's going to write back. We're going to write back the 5. Okay. The whole number is going to be the 4, and the remainder 1 is going to become the numerator. So you have your answer is 4 and 1/5, and you can check it, because when you multiply 4 by 5 you get 20. When you add the 1 you get 21 on 5. Okay, so your answer is 4 and 1/5. That wasn't so hard. And let's look now at changing a mixed number into an improper fraction. And you got a little sneak preview into that just now when we were checking to see if our improper fraction was correct. Okay, so we have here 5 1/4. Okay, but how do we change this into an improper fraction? Because currently it's a mixed number. Okay, what you do is you simply multiply the whole number by the denominator, and we know 5 4s are 20. And then after that, we add the numerator. So 20 plus 1 is 21. So our answer is 21 on 4. Remember I tell you that the 4 remains the same, denominator remains the same. So the answer in this case is 21 on 4. Okay. Okay, let's look at this one. We have 4 2/5. Okay. Again, to solve this, we simply multiply the whole number by the denominator. 4 5s are 20. And we're going to add the 2. So 20 add 2 is 22. So our answer, you guessed it right, is 22 on 5. The next thing we look at is the multiplication of fractions, and we did a bit of this in the beginning, okay? But we're going to go into it more in detail now, okay? And it's a very, very simple procedure operation. So let's say we have 4/5, and we're going to multiply 4/5 by 5/6. Okay, when we are multiplying fractions, okay, we can do a number of things. We can simply multiply the numerators and then the denominators. So you have 4 5s are 20, 5 6s are 30, so you have 20 and 30. That is one way of doing it. But then at the end of the day, you still have to reduce those terms. But what can be done is that it can be done before. In this case here, we have that 5 and 5 can be cancelled out or reduced, and 4 and 6. And we did exactly that, because 5 is going to 5 1, 5 is going to 5 1, 2 is going to 4 2, 2 is going to 6 3. And then we multiply, and we get 2 1s are 2, 3 1s are 3. We could have done it the other way, okay? And we could have had 20 on 30. Okay, and the 2 zeros could have cancelled out in the 20 and 30, and you will still be left with 2 and 3. So let's look at it another way. Okay, so let's look at this one here. Okay, say we have 7/8, and let's multiply this by 4/5. Okay. In this one, again, I would say we can simply multiply straight across the numerators and the denominators, and then we can cancel. In this case, the 7 and 5 can't cancel, but the 4 and the 8 can. So we can, because we can say 4 can go to 4 1, and 4 can go to 8 2. Okay. And then we're going to multiply the two numerators. 7 1s are 7, and 2 5s are 10. And it is that simple. Okay? So let's look at something else. Let's get rid of this. And let's look at something else. Okay, let's say that we had 1/8 and we were going to multiply it by 2/5. Again, we have the 2 and the 8 can cancel. Certainly the 1 and the 5 can't, because we can say 2 going to 1, 2 going to 8, 4, and then we can cancel, and then we can multiply our numerators and then our denominators. Okay, so 2 going to 1, 2 going to 8, 4. The 1 and the 5 can't cancel, so your answer is 1 on 20, because 5 4s are 20. Straightforward operation, very simple, very basic. Let's look at this one now. We have 3A's, and we're going to multiply that by 2/9. Okay, let's look at this. We know the 2 and 8 can cancel, and the 3 and the 9 can also cancel. So we're going to reduce this to, we're going to 2 1, 2 going to 8 4. We're working diagonally, and in the other one, 3 can go to 3 1, 3 can go into 9 3. Okay, so we simply multiply the numerators now. 1 times 1 is 1, and 4 3's are, you guessed it, 12. So the answer is 1/12. Okay, and multiplying is pretty straightforward. I don't perceive you will have a problem with this particular operation. And let's look at this one. We're going to multiply 4/5 by 3. Okay, yeah, let's look at this. Let's multiply 4/5 by 3. We know that 3 by itself is the same thing as 3 and 1. Okay, so let's rewrite the entire thing. We have 4/5 multiplied by 3 on 1. There is nothing here that can be reduced, that can be cancelled. Diagonally, 5 and 3 no, 4 and 1 no. You simply multiply straight across your numerators and your denominators. So 4 3's are 12, and 5 1's are 5. Your answer is an improper fraction, and sometimes you're asked to convert that improper fraction into a mixed number. And you did it before, I did it before. So let's do it and see what we come up with. 5 into 12. How many 5's can we get out of 12? I think 2, because 2 5's are 10, and the remainder 2. Okay, so in writing the mixed number, we can put 5 at the bottom for sure because we write that back. There are 2 5s can get out of 10, so that 2 becomes your whole number, and the remaining 2 becomes your numerator. And your answer is 2 2/5. Okay, let's do something else. Let's just get rid of this. Right. So let's look now at this one. Say you had 7 on 8 or 7/8, and you're going to multiply that by 4. Okay, as I said just now, a whole number by itself with the same thing is writing that whole number over 1. So 4 by itself in this case is 4 on 1. Okay, so we're going to rewrite the entire thing. So we're going to have 7/8 multiplied by 4 on 1. Okay, in this case here, the 7 and 1 can cancel, but certainly the 4 and the 8 can. We can get 4 can go to 4 1, 4 can go to 8 2. And if we multiply across, we get 7 ones are 7 over 2. Again, this is a proper fraction, and we can change it into a mixed number if we want. Okay, and we're going to do that now. 2 into 7. Okay, we know that 2 3s are 6, and you get 1 remainder. Okay, we know also that in writing this mixed number, the 2 goes at the bottom. Okay, there are 3 2s you can get out of 7, so that's 3 wholes, and there is a remainder 1. So your answer is 3 1/2. And the next thing that we're going to be looking at is the division of fractions. Yes, you heard me, the division of fractions. Okay, let's go straight to our examples. And let's say we had 3/5, and let's say we're going to divide it by 1/2. Right, so you divide 3/5 by 1/2. Okay, in dividing fractions, okay, there are 2 things you must do. In the first instance, okay, 2 basic operations. You write the first fraction 3/5. The division sign changes to a multiplication sign, and then we invert the last fraction. In this case, this is a half, so if it is inverted, we get 2 on 1, okay? And then we multiply like we were multiplying before. So we have 2 3s are 6, and 5 1s are 5. So your answer is 6 on 5. And it is as easy as that, okay? Again, 6 and 5 can be changed into a mixed number, and we know it's 1 on 1/5. 5 1 and 5 and 1 and 6. Very, very easy. Okay, let's look at another one. Let's look at another one. Let's get rid of this here. Let's say that this time we had 4 sevens divided by 1/8. Okay, remember the steps just now. First thing we do is to rewrite the first fraction, 4 sevens. Okay, then we change the division sign to a multiplication 1. Okay, and then we invert the second fraction. It is 1/8. If it's inverted, we get 8 on 1, or 8 over 1. Right, and once we have it at this stage, we can multiply it like how we were multiplying before. We have that 4 8s are 32, and 7 1s are 7. Okay. Again, we have an improper fraction that if we want to, we can write it as a mixed number, and that's something that we're going to be doing right now. So 7 into 32, we know that 7 4s are 28, and 28 and 4 will give us 32. So if we were to write this as a mixed number, of course, as I told you, write back the 7 at the bottom of the improper fraction, the 32 and 7. We know that there are 4 sevens that we can get out of 32, and the remaining 4, so your answer is 4 and 4 sevens, because 4 sevens are 28, and 4 is 32. Wow. Very, very, very easy. Okay, let's move on. Let's look at another example. So let's say we have 3/5, and we're going to divide it by by 8. Right. 3/5 divided by 8. 8 as a whole number. We know what I said before, 8 by itself is the same thing as 8 on 1. Okay, so let's rewrite these fractions here. We have 3/5. Okay, multiply, remember the sign changes. Okay, and 8 by itself is the same thing as 8 on 1. Okay, but we're going to invert that, and we have 1 on 8. Okay, there is nothing here that can be cancelled, so we simply multiply straight across. 3 1s are 3, 5 8s are 40, and your answer is 3 and 40. That was easy. And the next thing we're going to be looking at is working with mixed numbers. And our first example that we're going to put here is 4 1/2 multiplied by, let's say 4 1/2, and we're going to add this to 3 1/4. Okay, there are different ways of doing this. We can work with the whole numbers and then the fractions, or we can change each mixed number into an improper fraction and then work it like how we would work a normal fraction that has different denominators. Okay, so in this case 4.5 then changed to an improper fraction is 9 on 2, because we have 4 2s are 8 and 1 is 9, and 3.25 we have 3 4s is 12 and 1 is 13. Okay, so we have 9 on 2 and 13 on 4, and I hope you understand how we got these two fractions. Okay, again we have a situation where the denominators are different, so what we're going to do is we're going to multiply 9 and 2 by 4, which is the denominator of the other fraction, and then we can do the same thing with 13 and 4, where we're going to multiply it by the denominator 2 in the other fraction. So let's do that now. So we have 9 4s are 36, and 4 2s are 8s, and then over the other side we have that 32s are, you guessed it, you're so intelligent, 26. 32 to 26, and 2 4s are 8. So we have two fractions now, 36 and 8 and 26 and 8, that both of them have a common denominator of 8. So we can go ahead and we can simply add cross, just simply adding the numerators, and we're going to write back the 8. So 36 and 26. So I believe that you can finish this one on your own. But right now we're out of time, so I'll see you next time.